Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss one more important quantum mechanics, that is advanced quantum mechanics syllabus from the CSIR syllabus. Already I told you WKB approximation. From WKB approximation, one video I uploaded to you, and the latter after the WKB approximation, elementary theory of scattering is there. In elementary theory of scattering, two questions I told to you. One is the differential scattering cross section question, and one more question is I gave in yesterday's video, that is scattering amplitude dimension I told to you. So today after that, two approximations are there to get the scattering amplitude. Two approximations are there. One is Born approximation, another one is a partial wave analysis approximation. This Born approximation we also call it as a weak potential approximation. The partial wave analysis approximation we also call it as a low energy approximation, and Born approximation we also call it as a high energy approximation. So under the Born approximation condition, one question came. So we have to see how we have to solve the questions. Once you have to see CSIR June 2018, there was a question, the differential scattering cross section, the differential scattering cross section d sigma by d ohm, the differential scattering cross section d sigma by d ohm for the central potential. So for the central potential, we need to ask the differential scattering cross section for how much they are asking. What is the central potential? V of r is equal to beta by r into e to the power of minus mu r, where beta and mu are positive constant. Beta is greater than 0 and mu also is greater than 0. Both are positive constants you have to take. So beta is greater than 0 and mu also greater than 0. Positive constant is calculated in the Born approximation. So its dependence on the scattering angle theta is proportional to what? So it depends on the scattering angle theta is proportional to what? So that scattering, it depends on the scattering angle is proportional to what, where a is the constant below. We have to take, instead of beta you are going to take, instead of mu you are going to take it as a value you have to take, that is the constant value. How we have to solve this one, you able to see. So the scattering amplitude under the Born approximation, scattering amplitude under the Born approximation is equal to, there is a formula is there. So what is that formula? Once you have to see here, minus 2 mu is divided by h cut square into q, minus 2 mu is divided by h cut square into q, integral 0 to infinite r dash v of r dash sin q r dash into d r dash. This is the scattering amplitude for the Born approximation. So what they are asking? They are asking about the scattering amplitude. So dependence of theta under the Born approximation is proportional to what they are asking. So is proportional to, instead of q you have to take it as a k, you have to take 1 by k into integral 0 to infinite r into v of r into sin kr, we have to write it is sin kr into dr we have to write. So but you know that under the central potential v of r is equal to beta by r e to the power of minus mu r. V of r is equal to beta by r e to the power of minus mu r. So that value you have to substitute here. So what is going to happen? You have to see f of theta. So under the Born approximation is directly proportional to, beta is the constant, so that's why proportional symbol I have to take 1 by k into integral 0 to infinite r into e to the power of minus mu r is divided by r into sin kr into dr we have to write. So one r get cancelled. Therefore, how much value is there? So, that value you have to write f of theta, the scattering amplitude under the Born approximation is directly proportional to 1 by k into integral 0 to infinite e to the power of minus mu r into sin kr into dr. But you know that sin theta is equal to, you have to expand in terms of the exponential factors, you have to expand. F of theta under the Born approximation is directly proportional to 1 by k into integral 0 to infinite e to the power of minus mu into r sin kr is equal to e to the power of ikr minus e to the power of minus ikr is divided by 2I into dr we are writing. So, e to the power of ikr, e to the power of minus ikr is divided by 2I. So, this 2I you have to bring into this side. F of theta under the Born approximation is directly proportional to 1 by 2ik. So, integral we have to write integral 0 to infinite. So, you able to take instead of one integration you are going to get it as a two integrations you are going to get. So, minus r into, you able to take mu minus, you have to write it as a mu minus ik you have to write. So, mu minus ik into dr. So, minus you have to take here integral 0 to infinite. So, integral 0 to infinite you are going to take it as a e to the power of minus r, you have to write it is you able to take it as a mu plus ik into dr. So, the bracket close you are going to take. So, now you have to substitute that formula. So, what you are going to get it, the scattering amplitude under the Born approximation is directly proportional to 1 by 2ik into, so 1 by 2ik into, you have to do the integration, what you are going to get it as 1 by square root of mu minus ik, you are going to get 1 by mu minus ik. So, minus 1 by mu plus ik you are going to get it. So, this is the, so based on the integration you have to do this one. So, therefore, the scattering amplitude under the Born approximation is directly proportional to 1 by 2ik. You have to take it as a LCM mu square plus k square, because it is a complex number, mu plus ik minus mu minus ik you have to write it is. So, minus mu plus ik you are going to take minus mu. So, which one you have to write it as, you are going to take so mu you are going to write it is mu plus ik you have to take. So, mu minus mu plus ik minus mu plus ik you are going to get. So, now you are going to take it as that one. So, 2ik f of theta under the Born approximation is directly proportional to, so 2ik is divided by, so 2ik is divided by 2ik into mu square plus k square, you are going to get it. So, mu ik get cancelled. F of theta under the Born approximation is directly proportional to, f of theta under the Born approximation is directly proportional to mu square plus k square all to the power of minus 1. Instead of mu I have to take a. So, that is why what we have to write it is, we are going to take the scattering amplitude under the Born approximation is directly proportional to a square plus k square, a square plus k square all to the power of minus 1. But you know that, so what do you know, k is a momentum transfer is equal to, we have to write it is directly proportional to, we have to write it is k is directly proportional to, you able to take k is directly proportional to sin theta by 2. So, therefore, k square is equal to sin square theta by 2 you have to write. So, therefore, what we have to write, you know that f of theta under the Born approximation is directly proportional to a square plus sin square theta by 2 all to the power of minus 1 we are going to get. But what they are asking, the differential cross section under the Born approximation is equal to what we have to write. It is modulus of, so modulus of this one you have to take so a square plus sin square theta by 2, so minus 1 whole square is there, that minus 1 into minus 2 you able to get it. So therefore how much you are going to get, that is the differential scattering cross section, under the Born approximation is directly proportional to a square plus sin square theta by 2 whole to the power of minus 2 you are going to get. So this is your answer. Like this you have to do in your competitive examination. Once you have to check the answer, whether answer is there or not in the options. Option A is wrong, option B is wrong, option C is correct. So what is that option C? A square plus sin square theta by 2 whole to the power of minus 2. So this is the value you have to see. So before going to do this one, we need to know what is the Born approximation, what is the scattering amplitude of the Born approximation, how we have to derive. Inside the equations also we are going to get it clear. So now already we are informing, daily we are informing, we started the CSIR and GATE physics online mode coaching we are starting. So we have one app, that is Quantum Online Academy app is there. So DL physics and JL physics content also we are giving in our app. So once you have to download our app from your Play Store. So after downloading our app, you able to see the courses. CSIR and GATE physics course will display like this. JL and DL physics course will be displayed like this. Not only that, individual papers also available according to your CSIR syllabus. Till now we are finishing the mathematical methods of physics, and the second paper classical mechanics also we are finishing. The third paper is electromagnetic theory we are finishing. The fourth one is quantum mechanics we are going to be finished, because under the last topics we are there. So 2 topics we are left behind. If we finish these 2 topics, entire the quantum mechanics portion also recorded classes are available in our app. Once go through our app, if any problem is there, you have to contact with my mobile number. So my mobile number is 9908437460. You have to call me and you have to negotiate me. If you really likes my teaching, you have to listen all the YouTube videos. Later you decide whether you want to take the course or not. So if you have to take this course, is really useful to you to crack any competitive exam after masters. Clear? Thank you so much. Please share and subscribe and like our YouTube channel and touch the bell button. Thank you so much.